Students, welcome to another chapter, that is mechanical properties of solids. So this chapter comes under the second part of NCERT textbook, and you have one more chapter along with this, that is mechanical properties of fluids. Okay, so we will see this mechanical properties of solids. This chapter you will be getting a total of 4 marks from this chapter, and the question may be asked like one 3-mark question and one more 1-mark question. Okay. Then you will be having like 2 practicals from this chapter. That is, one is to find out the Young's modulus, which we will be discussing later. One more is to find out the force constant. Okay. Now, what are these mechanical properties? There are some examples given over here. You can see this. First one is elasticity. So elasticity is a property of a body which regains its original shape after you remove the deforming force. If you take certain rubber or something, rubber is not actually the elastic material, it is something different which I'll tell you later. For the time being, we'll take it as an example. So when you pull this rubber, okay, and when you leave it, what happens? It goes back to its original dimension, right? If you pull it, it will go back to its original length. Okay, so elastic property means where the material is going to regain its original shape or size, or we call it as original dimension. Then next one is plasticity. If the body is not able to regain its original shape or size, then we call it as plasticity or the plastic body. Okay. Then strength, you can understand the strength of the material is nothing but the ability of the materials to withstand certain applied force. Then the next property is hardness. It is the same thing. What about strength? Both are same. Okay. Then ductility. So ductility means it can be made very thin. So you can continuously apply force and you can make the material very thin shape. Okay. So thin means you can make it like a small, very small dimension of the thickness. Next one is about brittleness. Okay. What is this? Brittleness means it is hard but breaks very easily. So you must have seen the glass. Glass looks very hard, but when you apply some force, it suddenly breaks. Okay. Next one is about malleability. So malleability means the material can be hammered to very thin shape. So this malleability and ductility are considered to be the properties of metal, which you will be studying in your chemistry. So if you consider the making of gold ornaments, what do they do actually? They apply a lot of force, continuously they apply, then they make the gold sheet or the gold whatever they get from the mining, it will be made to undergo different processes, and finally what they get is a pure gold which will be mixed with some other alloy like copper or something else, and what you get is a 916. So it is a 22 karat gold which is considered to be the purest one used for making ornaments. So in this 916, if you see this 916, actually if you take 1000, in that 916 is will be gold and the remaining will be some other materials. Okay. Then toughness. Toughness you can identify for the bulletproof glass. If you consider the toughness of the glass, we usually say, right? So whatever force, even if you apply a lot of force, it is able to withstand that force. That is what we call it as toughness. Okay. So these are the mechanical properties of solids. Now we will see what are these solids actually. So solids are considered to be rigid bodies, or these rigid bodies are certain bodies which will not change its dimension even if you apply large force on it. That you will be studying in the system of particles. Okay. So we will see this rigid body, that means a body which can maintain its dimension even if you apply very large force on it. Okay. Now we will see these 2 properties, elasticity and plasticity, and all these things will not be studying. Okay. Now what is this elasticity? I have already told you what is this elasticity. So you can get number of different types of definitions, and whichever definition you feel easy for you, you can refer with that. Okay. So the definition what I have given here, the property to restore the natural shape or to oppose the deformation is called elasticity. So it is a property, correct, right? It is a mechanical property. Okay, what do the material do with this property? It can restore natural shape or oppose the deformation force, okay, or deforming force, or oppose the deformation that is happening to that particular material. Now, if a body completely gains its natural shape after the removal of deforming force, we call it as perfectly elastic body. See here, if the body can regain its original shape perfectly, like if you have a metal over here and I'm going to bend it, okay, so I apply some force and I bend it. If the body regains its original position after I remove this force exactly on the same position, if it regains, then I call it as perfectly elastic body. Okay, now we will see what is perfectly plastic or perfectly inelastic. So if the body remains in the deformed state or shape and does not even partially regain the original shape after the removal of deforming force. So if you take some mud or even your chapati, okay, and if you apply some force on that, what happens? The deformed shape will remain forever. It will not regain its original shape, right? Correct. So that is nothing but perfectly inelastic or plastic body. Now we will see from where this elastic behavior in the solids originates. Okay, so we can consider, like, you know, there are different states of matter. One thing, you know, gas, okay, then you know, liquid, then next is nothing but the solid. Okay, now one more, there are two more which you don't usually come across. That is, one thing is plasma, okay, another one is Bose-Einstein condensate. Okay, so this plasma actually observed at very high temperature, where you will have a lot of gas ions. So when you heat the gas to very high temperature, you will have a conducting medium. Okay, that is nothing but plasma. At the same time, when you cool a substance to very low temperature, then what you have is a Bose-Einstein condensate, where almost all the atoms will be inactive. Okay, now we will see the solids. If I take some gas, okay, you know that molecules are differently, like far away they are distributed. This is gas. If I cool it, then it becomes liquid, right? That means what happens? Molecules come closer. Again, if I cool it, then what I get is a solid. So we say that in the solids, atoms are very closely packed. How? Atoms are very closely packed. But that's what I told you. If you consider this solids are rigid body, it is not possible in the nature to have a perfect rigid body. So whatever we say perfect, that is not possible in the real life. Okay, now you must have studied the shape of the solid in this way. Okay, that is what the atoms are closely arranged. But if you see the actual structure or the microscopic structure, what you see, atoms are bounded by some kind of imaginary force that is not possible to observe, and we call it as bonding. What we call it? We call it as bonding. In chemistry, you people will come across different types of bonding, like ionic bonding, covalent bonding, all those things. So in this bonding, what actually happens here is the atoms are arranged, like we can take an example of this is considered to be ball, and these are nothing but spring. So you can have a structure where different balls are taken, and you will be connecting them with the spring. So if I apply a force over here, okay, now what happens? This will get compressed, right? So the ball will come over here, okay, this length will decrease. See, you will get a structure like this, correct? Okay, so it will be displaced to this position. when I apply some force on it. So you can see here, like when you cool, what happens? Molecules will come closer, right? Why? Because the force of attraction between the molecules increases. Similarly, when you apply some force on this, what happens? The molecule will come closer. Okay. Now, if I remove this force, okay, if I remove this force, what actually happens? The spring again goes back to its original position. Now, what happens here? The molecule regains its original shape. So, this is nothing but the elastic property what you see in solids. Okay. Now, the one who studied about this property of elasticity or the law of elasticity was Robert Hooke in the year 1676, and he put forward the idea of Hooke's law. So, this Hooke's law says that the displacement, whatever happens, will be proportional to the force applied. Okay, the displacement happens to the position will be proportional to the force applied. That means if you apply larger and larger force, what happens? Displacement will also become smaller and smaller, or it will be get compressed. Same way, if you elongate it, whatever force you are applying, okay, the same way the displacement will also increase. So that is about the elastic behavior. Now, to explain all these ideas, we need to go across different terms related to this topic. So first one, what you have is a stress. Okay, stress is nothing but restoring force per unit area. So you usually say, like, you get stressed. Okay, so that doesn't have anything to do with this stress. Okay, that is another way in the daily life, whatever we happen, like we say we are having stress, or you say after playing or something, you say like I have strain in my legs. Okay, that is nothing to do with this one. Here we are mainly focusing on the certain solid materials. Now, restoring force per unit area is known as stress. Now you know that when you apply some force, there will be a restoring force produced in the opposite manner. So if this is a elastic material, and if I try to compress it, what happens? Equal amount of force, whatever I am applying on this one, equal amount of force will be developed inside that, and it is going to bring back the whatever displaced atoms or molecules to the original position. Okay. Now, we can say this magnitude of stress is nothing but force by area. So this force is nothing but restoring force. So this is the mathematical notation of stress. Now SI unit of stress is Newton per meter square. You can understand F for Newton. Okay, then A is nothing but meter square, but as it is in the denominator, you will get a minus sign over here. Otherwise, you can also call it as Pascal. Okay, so Pascal is a unit of pressure also. So if you take this magnitude, or if you this magnitude of stress, dimensional formula of this stress is nothing but m L to the power minus 1 and T to the power minus 2, and it is a scalar quantity. Okay, so stress is nothing but a scalar quantity. The next term what you need to study about this ideas like strain. Okay, so what is this strain actually? It is a ratio of change in the dimension to the original dimension. So strain is nothing but change in the dimension to the original dimension. So dimension means, you know, right? What are dimension? Length, breadth, height, all these are dimensions. Correct? So if there is any change happens to this dimension, and the ratio of that change with the original dimension is known to be strain. Now we will see different types of stress and different types of strain.